All right, good morning. Happy Thursday. Enjoy the nice warm weather today, even though it is going to rain a little bit. But today we're going to look at graphing some logs. So things we need to remember, how these transformations work. So let's start with our parent function, log base a of x, whatever that log is. So that log function, like we've been saying, is the opposite or the inverse of an exponential function. So let me get my graphing calculator out here. Where did I put that? And if we remember, our graph of 10 to the x looks something like that. Had our horizontal asymptote at 0, and if we do the log of x, that's going to look something much more like that. So let's start with our log base 2 of x, and you know what? Like we always do, we're going to make our xy table. And let's just start with some powers of 2. So we'll start with 1, and then 2, and 4, and then 8. So now we've got to think log base 2 of 1 equals x, or 2 to what power gets me 1? Well, it's got to be 0. So 2 to the 0 power gets me 1. And now, log base 2 of 2 equals x. 2 to what power gets me 2? It's going to be 1. 2 to what power gets me 4? It's going to be 2 squared. So 1, 2, 3, 4. And then 2 to what power gets me 8? Well, that's 2 to the third. 1, 2, 3, 4, 5, 6, 7, 8. And if you wanted to, you could go, 2 to the 1/2 would be a -1. 2 to the 1/4 would be a -2. 2 to the 1/8 would be a -3. And what you can see here is this graph is kind of hugging the y-axis. Kind of hugging that y-axis. So our domain, our x values. So here's my x-axis. What x values am I getting here? I'm just getting x such that x is bigger than 0. So no matter what number I plug in, 2 to the -1 millionth power, I'm never going to get 0. This might be misleading. Let call this y. But what's my range? What y values can I have? And, this arrow here suggests that that's going to go up and right forever. So this is where it's a little bit different than our exponential functions. This is all real numbers. So now let's check out our end behavior. So when y, or f of x, is going to infinity, so as our y values go up, where is my x going? Well, as my x values get bigger, as I go this direction, my y values are getting bigger. And then as x approaches 0, because again, x has got to be bigger than 0. So as x approaches 0, as I get closer and closer to 0, my y values are going down. So this was infinity. This was 0. What's my x-intercept? Where am I crossing the x-axis? So where is my y value 0? Here. I'm crossing that y-axis, or sorry, the x-axis here at 1, 0. There we go. Another way we can find this pretty easily is we can plug in 0 for the whole function and see what, the whole function. Plug in 0 for y. So 0 for y, and then solve. It's another way of doing it. And our asymptote, what line are we not touching? Well, it's right here. Because this can go kind of up and right forever, but we're not crossing that vertical line of x equals 0. So you can see this number, that number, all 0. So x is approaching 0, x equals 0, x is bigger than 0. All those numbers are going to be the same. So this one's going to be a little bit tougher. I've got a 1/3. So let's do x, y table. Let's do powers of 3. So let's say, well, we start with 1. And then we'll go to powers of 3. So 3, 9. That's really all we can do. So let's see. Y equals log base 1/3 of 1. So 1/3 to what power gets me 1? So anything to what power gets me 1, it's got to be 0. So 1, 0 is a point. Now let's look at log base 1/3 of 3. Or 1/3 to what power gets me 3 over 1. Well, if I flipped my fraction, what kind of power do I need? What kind of exponent flips a fraction? It's got to be a negative. 3 to what power is 3? It's negative 1. And then similar thing here. Log base 1/3 of 9, or 1/3 to what power gets me 9 over 1? Well, I flip my fraction, so it's negative. 3 squared is 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and a negative 2.